Good morning and good afternoon, and welcome to this presentation on what is STEM. We're going to explore the connection between science, technology, engineering, and math. Now, here's the deal. If you are watching this and you are in Mr. C's class, you're probably thinking, well, I already know what STEM is because Mr. Cato, you told us at the beginning. It's science, technology, engineering, math. That's what it is. Well, yes, but what does that really mean? Okay? Is it just science? Is it just technology? Is it just engineering? Is it just math? Or is it a combination of all of those? Well, we're going to explore that just a little bit. Now, if you've stumbled across this video, across the various searching for the internet, thank you so much for watching. Please understand the context here. The context is for 6th grade students in a middle school STEM class. So that's kind of where we're at with this. But congratulations. Maybe you'll learn something new. Welcome to the presentation. All right, let's go to the next slide. Here's what we're going to look at, okay? We're going to look at and explore the concepts of STEM physical science. Now, STEM, you might have environmental sciences, right? Or STEM, you might have other kinds of science, but the emphasis here is on the physical sciences. In other words, we're going to understand the ideas and consider ideas and maybe even start developing those critical thinking skills about science and technology and engineering within the physical science world. In other words, the physical science are the things that are around us that cause things to happen, and think like forces of motion and energy and transfer of energy and kinetics and all that kind of good stuff, all right? So those are the things that we're going to be looking at and exploring here when I say physical science. Now, everything integrates, okay? Everything integrates. Science integrates with math, which integrates with technology, which integrates with engineering to give us certain different things. And then we're the benefits of that because people have done a lot of work in the past about this, and people are still doing good work with it. So we're going to explore that in more detail, all right? So think about what happens with a typical rocket launch, right? When a rocket launches, there are powerful forces that are happening, right? But did that just happen on its own, or did somebody need to think of the process and did it need to be refined as it moved forward? You see, the cool thing about the rocket launch is that there are definitely different things going on with the STEM world in that. There's a little mixture of science. In other words, well, we'll look at what science is. There's a little bit of difference and mixture of technology in that. Even with the old school rockets, there's still some technology that's going on. There's a lot of engineering that's happening, and there's definitely some math and some calculations that are going on to make those things happen.
5, 4, 3, 2, 1, ignition, and liftoff. Go Falcon, go Dragon.
And liftoff. NASA SpaceX's 33rd commercial resupply services mission is on its way to the International Space Station.
Operation confirmed.
About 2.5 minutes in. And there you can see the great quick sequence of events.
Wow. See, right there is an absolute demonstration about, well, the different things of STEM that we need to think about. Example, for that rocket to go up, there needed to be a complex understanding of thrust. In other words, the power to lift it above the atmosphere into orbit. You also needed to understand, or the designers needed to work with drag, the resistance against the forward motion. Then there was lift, the force that elevates the rocket, which, it happens through the thrust. And of course, weight, that is the gravitational pull on the rocket. So there's a lot of different things that are happening at one time with that particular launch. And then if you noticed, there was, in that particular video, it was speaking about going to the International Space Station and staying. So there had to be calculations to get that not only into orbit, but in orbit fast enough where it could reach the International Space Station and dock with it at the same time. A lot of math, a lot of science, a lot of physical science, a lot of engineering, all right, involved with that. And of course, science. So let's dive deeper here, all right? Let's look at how STEM might collaborate within all the different types of scientific fields, okay? And I say all loosely, these are dealing with physical sciences, okay? Not biology or what have you, all right? So, STEM works with science. In the case of that rocket, what are the forces of motion and energy at play? With that rocket, STEM might deal with the technology, everything from the materials that the rocket is comprised of to the fuel, to how that fuel is delivered, and even navigation systems, right? The technology or the computer systems at play. And then, of course, there's engineering. Do you think they were able to get something up in orbit the first try? No, they had to iterate or change the design multiple times to make it work. And that's the engineering process. And of course, there was math at play with calculations and rates. So let's go dive deeper into here real quick on this slide, all right? Science, we could say, is the study of nature and why things occur around us the way they do, all right? In the case of physical sciences, we're thinking forces and energy, okay? Technology isn't just computers and calculators and what have you. Even the wheel was considered new and technical and technology at the time, right? So you got materials and design and computer systems, right, that make up technology. And of course, the science of how electricity is used in data and what have you. Then there's engineering, right? Engineering is the study of design and how the forces of nature work and might be changed or manipulated to serve a function. And of course, with design, you need to change the designs if something is not working or needs to be improved. And of course, there is math, right? And math is used to provide the calculations to see if something works, right? They all tie in to each other. And that's why, of course, we have the word STEM, right? STEM isn't just science. It's not just technology. It's not just engineering. It's not just math. It's about using all of those things together. All right, so again, like I said, science is the study of the natural world. Technology is the tools and systems to solve problems. Engineering considers the design and building of things, and mathematics is the language of patterns and, of course, quantities. Right? This is all all of the integration into STEM. Okay, and many of the fields that deal in STEM will integrate these components, but you might specialize inside the individual fields, if you will. All righty. So, if you're in class, we're going to do a little pendulum experiment. If not, I'm going to fast forward through this video and go to the next key idea, okay? And I just wanted to go here. So if we're in class, I'll do this in that pendulum example. If not, well, there you go, all right? So, quick thing here, connecting things, right? The connection of the webs, right? Again, science, we're understanding physical laws and principles. Technology, we're using tools to innovate and design. Engineering, we're creating solutions through the design process. And mathematics, we're analyzing data to support findings, right? So again, we're connecting those things, okay? Connecting those things together. And with one thing, we might use all four areas. Example, a rocket launch. Or maybe flying something through the air or underground, right? Or maybe designing a smartphone or a computer, all right? All of those things go into, well, STEM itself and might affect the way that things go together, okay? So, let's look at some real-world examples here, all right? I just used the word smartphone, right? Kind of introduce you to this idea, right? Smartphone utilizes electricity and electrical currents, okay? That is science. Then those electricity and those currents might have data going through them through a digital envelope. If you don't know what that is, that's fine. But basically, that's the technology or the circuits at play. And then you have the engineers who design the basic phone itself. And of course, math is the algorithms going on in the background and the ability to calculate and do what the user wants to do and the software interactions and what have you. If you don't like that analogy, think of something a little bit more fun, like roller coasters, right? Roller coasters, you're thinking about science with physics, right? What is at play, especially with energies and things in motion? Then, of course, you've got technology, everything from sensors on the carts to the way that maybe the safety bar comes down over you, or the automatic brakes that are working, or maybe propulsion systems with like the launching things, right? You got engineers with the structures and how the cart might turn or do its loops and all that good stuff. And of course, math, you're making calculations because you don't want to have G-forces that are beyond what the average person can withstand, because you might really hurt somebody or injure somebody. Or think of the natural world around us with weather forecasts, right? Science, you got the understanding of how the atmosphere and the air works with meteorology. Then you're integrating things like satellites and other measuring equipment, right? With the technology. Then engineering, you got the design of those equipments and the design of those satellites, right? And how they're going to get into orbit. And of course, math, you got the things that are help with the forecasting and the models and, what things might look like a few days from now or what have you, okay? So again, the world of STEM and the integration of STEM and the integration of all the concepts of science, technology, engineering, math is all around us, all right? So here's a couple of key takeaways. Integrate, right? Integrate is to kind of put things together, right? STEM enhances learning experiences. Why? Because we can start putting ideas together, right? STEM enhances collaboration because engineers got to work with the guys in the technology, and the guys in the technology got to work with the world in science, and they got to work with the math and all that good stuff, right? And then, of course, you might have exploration of these ideas, right? You might be fostering curiosity. You want to discover, so you got to explore these things, right? So STEM helps us also, maybe explore through the resources and the internet and what have you. And, of course, you got the application where real world problems inspire the actual solutions themselves. All right, guys, so that brings me to the end of this presentation. I hope you took something from this, and the biggest thing to take away is, hey, STEM isn't just dealing with maybe Ozobots or 3D printers. It's utilizing everything, right? And we got to start putting those components together. Now, as we continue with STEM class, we're going to be looking at those contents and those ideas specifically and individually, okay? But think about how they all integrate with each other. Thank you so much for watching.